A monomial. Mono means one, so it's single term. But a single term can be made up of more than one thing. They're just attached together with multiplication. So a monomial is going to be a constant, which a constant is just a number, like 5 or 17 or negative 32 or 5 million. But it's got no variable. It's just a number. So a monomial can be a constant. It can be a variable, x, y, q, p, whatever. Or it can be a product of a constant and a variable. So 2x. It can even be more than one variable. So it could be 13xyz. It can be 13x squared y cubed. What it cannot have is addition, subtraction, or division. So 2x plus 3 is not a monomial. All right? So what you do is to determine if things are monomials. I look at this as just a constant. So we'll just use a y for yes and an n for no. So yes, that is a monomial. We don't need to explain it. It's just a number by itself. F plus 24. No. And that's because it contains addition. So that makes it not a monomial. H squared?
Yes.
Yes. 5j.
Yes.
5j is good, yes. MP divided by n.
What if 5j had a multiplication symbol between it? No.
Yeah, if it had a multiplication symbol, that's okay. So you mean like if it was 5j?
Yeah.
That's still a monomial. It's okay because they have multiplication. Multiplication's good, but nothing else. And this is going to be a no. That's a bad n. I don't like that n. And the reason is because we're dividing by n. So we can't have division. Powers and exponents, 2 words, means the same thing. It is a shortcut for repeated multiplication. Multiplication has an I in it. Okay. What we have here is 6 to the 3rd. 6 is known as the base. The 3 is called the power or the exponent. And what this means is that we're multiplying 6 by itself 3 times. So it's not 6 times 3, but it's 6 times 6 times 6.
Squared, right? No.
Cubed,
Cubed, yeah.
which was probably a bad example now that I'm looking at it written all out, but
6, 6, 6.
we'll just make these dots bigger. Okay, so 6 times 6 is 36, and then I have to multiply that by 6 again. So that's 216. Okay. Exponents get very large very fast. Products of powers. Now when you are multiplying, you must have a common base. And this just means that your bases match. Okay, so here on my first example I have x cubed and x to the 7th. The x's match. They have to match, right? And when this happens, we add the exponents. Okay, so x cubed times x to the 7th is going to be x to the 3 plus 7, which is going to be x to the 10th. Does anybody need to see why? Would anybody like to know why that's the case?
Just added the exponents.
I added the exponents. Okay, so in this example I have multiple variables. I have p's and t's. Now this p does not have an exponent, so it's like there's a little invisible 1 there.
It's a 1.
Even though all being multiplied together?
Well, and I'm just going with there, if there's no exponent, it's the same thing as being a 1, because p to the 1 is just 1p, right?
The
So there's
exponent
just
only
p.
affects the number, right? And the
Mhm.
coefficient affects
So
all.
3p, 4t.
Yeah. So
So, yeah.
this 3, there's nothing to multiply it to,
So it's just itself.
so it's going to be 3. Okay. It's going to have 1p and 3 more p's, so 1 plus 3, so p to the 4th, and then t3 and t4, so t to the 7th.
Are subscripts in this chapter?
No, only exponents. Okay.
This is
Now,
multiply.
if we have coefficients on both, these are being multiplied.
So that's like 12 and 10.
Exactly. So I'm going to multiply the 6 and the 2. So I get the 12, and then 3 ends, 7 ends. So I add 3 plus 7, and I get 10. 12 ends to the 10th. So what we do next is I have -4 times -6, so that's going to be positive 24.
24 R6X 4 T4.
Yeah, there's 1 R and 5 R's, so R to the 6th. 2 X's, 2 X's, so X to the 4th. 3 T's, 1 T, T to the 4th.
Careful that.
Okay, and before I go further, you'll notice the difference. If you look at these examples, you'll see you have one set of parentheses with a power outside, whereas on this you have parentheses next to each other. Okay, so that this is being multiplied together, this is being raised to a power. And when that happens, we multiply, sorry, hold on, we are going to take any coefficients to the outer power, and then we multiply any exponents.
This is a coefficient.
The coefficient is the number, oh wait,
Isn't there only a coefficient?
there aren't any coefficients on here. So on this one, we're just going to be taking 2 powers. I didn't put any variables in there.
Would the first one be
Coefficients
12?
though,
I think it is.
are numbers attached to variables. So like if I had 2x, 2 is the coefficient. In these first examples, there aren't any actual coefficients. Yes.
Slightly remember something like this. Doesn't it just like the number on the outside of the parentheses add in?
Not adds.
Well,
Multiplies.
So multiplies it.
Mhm.
So okay, so it'd be like
So what I'm going to do is I'm going to
12.
take this 3 and I'm going to multiply it by that 4. That arrow is
so that'd
awful.
be so that'd be 12.
Yeah, like that.
But would it also multiply the number or
No. We exponents raised to powers multiplied by exponents. So this would be 2 to the 12th. Okay. Here, 5 to the
40th.
40th. Now,
And then the fun one.
here, I start inside. My order of operations tells me I start on the innermost and move out. So I'm going to do 2 to the 5th first, or 3 to the 5th squared. So that gives me 3 to the 10th.
And then like 3 to the 50th.
Then that's raised to the 5th. Now, can anybody tell me quickly what 3 to the 50th is?
Oh.
No? Okay, that's fine.
Well, does what? Does like
That's
a
okay. I can't do it
specific
either.
name?
So, no. I was at the number.
3 to the 50th?
Yeah, I'm kidding.
And then add it into zeros, I don't know.
No, it's not 150.
Where'd you
Because
get
it's
that?
3 times 3 times 3 times 3, 50 times. There's no way anybody could do that in your head right now. like that anyway. You might be able to do it in your head, but you wouldn't be able to do it like that. But this you can do pretty in your head very quickly. 4 squared squared. It's 4 to the 4th.
Then 4
to the 10th. So it's going to be 4 to the 40th. Now, if you mess up the order on that, do you think it's going to be terribly tragic?
Maybe.
Multiplication is commutative. So what happens if I did 5 times 2 first? I'd get 10 times 5. So I'd still get 50.
But what about the other one?
10 times 2 is 20.
Okay, so
Times 2, 40.
Nice.
So it will not, you're supposed to move from the inside out.
Go in.
But
go
if you
out.
accidentally go from the outside in on these, you'll be okay.
Yay. Safety net.
Okay, so yeah, it's sort of like distribution, but instead of distributing a number that I'm multiplying in from the front, I'm distributing a power to everything inside. So this squared is going to affect the 3 and the x. So what's going to happen is I'm going to, in this case, get 3 squared x squared. Now, 3 squared is small enough that I don't want you to leave it 3 squared. Now, if it was 3 to the 15th, leave it 3 to the 15th. That's fine. But 3 squared, that one's easy. You could do that. So it'd be 9x squared. Basically, if the exponent is 5 or less, I want you to actually work it out.
What if it's 15 to the 4th?
You can plug in, you just multiply 15 times 15 times 15 times 15. So, but it's,
So-
you can plug it into your calculator 4 times. That's not
Yeah.
unmanageable, but if it was like, 15 to the 10th, that's a lot of, I'm not going to make you do that.
So like with the one with the 5 to the 4th, that would be like just instead of having it 5/4, it would be 20. Like
Well,
you'd
no,
want us-
it's going to, oh, here?
Yeah.
Yeah. So I'm distributing that exponent to the 4,
20
to the
x
x,
10 to
and to
y
the y.
20.
Well, it's 4 to the 5th,
Yeah, but would
x to the 10th,
don't you want that to
y
be
to the
20?
20. Oh, it's not 20 though, because it's 4 times 4
Oh, yeah.
times 4 times 4. So 4 times 4 is 16,
Times 4.
times 4 is 64, times 4,
Is it 300?
64 times 4 is 256, times 4. That one I can't do in my head.
So I guess leave that alone.
Well, I can do it.
No, I mean like on the paper. You just like leave it as 4/5 instead of actually.
You could.
Number.
So 1024. So 1024,
That's 1,000 number. Yeah.
x to the 10th, y to the
You
20th.
want to simplify it like that?
If it's 5 or less.
Oh, 5 or less?
The exponent or the.
The exponent. Okay, so pi is 3.14. Our radius is 2xy squared, and then we need to square that. So we're going to distribute this 2 in to all of our parts. And so this is going to be 3.14 times 2 squared x squared y to the 4th. So far, so good? Okay, 2 squared is 4.
It was on the radius.
It was right here. This 2 or this 2?
That one.
This 2 came from the pi r squared, so if we had to square the radius. So that's 4x squared y to the 4th. And then I just need to do 3.14 times 4. So that's 12.56 x squared y to the 4th. Now, if you did not want to actually multiply in the 3.14, we could have left it as pi. And what we'd had is 4x squared y to the 4th pi. If you had left pi. Both of these answers are correct. So you can leave pi in there if you want, or you can multiply pi as a number. It's up to you. So, a monomial is completely simplified when it meets these criteria. So every variable is appearing only once. So if you look down here, I've got more than one y. This is not simplified. There are no powers of powers. So here I have powers of powers. That's not okay. And all fractions are in the simplest form. So once we multiply everything together, if there are any fractions, we have to reduce them. Okay, and that's when a monomial is completely simplified. Basically, a monomial is simplified when you've done all the math you can possibly do to it. So what we do, I got a lot going on here, right? This has something I need to do to it, this first half, and then so does the second half. So before I can multiply these two things together, I need to make sure that each one is completely simplified. So first I'm going to distribute in this power. So I've got 3 squared, so that's 9. X squared. Why is this so... Ooh. Hold on, let me rewrite that. So 3 squared was 9, x squared, and then y to the 8th. Okay, so that part's done. Now this is a power and then another power, so I'm going to have to do 2 things to this one, the second part. So first I'm going to distribute in this 2. And that's going to give me, okay, -2 squared. That's -2 times -2. If the negative is inside the parenthesis, it is also being squared. Okay, so just, I'm going to put that over here, like that. If the negative is not inside the parenthesis, it's still negative. If the negative is inside the parenthesis, it'll be positive. So this negative is inside the parenthesis, so that's going to be +4 y squared, and then I need to take that to the 3rd. So I will do that. So this gives me 9x squared y to the 8th.
Didn't you say it was like 64, 68?
64. Well, 16. 4 times 4 is 16 times 4 is 64. So 64y to the 6th. Now I can multiply these together because I can't do anything to either one of them individually anymore. So that's going to give me, anybody know 64 times 9 off the top of your head?
Can't they not go together because one of them doesn't have an X?
It
I
does,
was
no,
about
they
to say
can.
576. I didn't.
They can, because what I've got here is I just bring this x squared over because it's all being multiplied together, so it just hangs out. So the x squared gets brought over. So I multiplied the 9 and the 64. There's nothing to multiply the x squared to, so I just carry it over. And then y to the 8th times y to the 6th. Remember, they're multiplying, so I'm going to add the exponents. Good question. So guys, just a rule. If I have a negative number and I take it to an even exponent, I get a positive answer. If I have a negative number and I take it to an odd exponent, I get a negative answer. And the reason being is because even exponents are pairing everything off, and anytime you have 2 negatives being multiplied, it ends up being positive. So you have a bunch of pairs that give you positives. With odd exponents, you have a bunch of pairs and one left over. So you have a bunch of positives multiplied by that final negative. So this is a nice rule to know, because this way you don't have to worry about keeping track of the signs while you're multiplying. If this is negative and that's even, you're going to have a positive answer.
Like squared.
Squared, 2. If your exponent is 2, 4, 6, 8, 10, 12. And here, if your exponent is 3, 5, 7, 9, 11, etc., you'll get a negative answer. So that's just a nice little,
You know, on Snoopy, whenever he talks, and it's like, yeah.
What's that movie where they try to talk to the aliens with the piano? Close Encounters of
third kind.
Third Kind?
Yeah.
Okay, I'm gonna do both of these in the same step, like that. So I have a half to the power of 3. Okay, well, let's do that real quick. 1/2 to the power of 3 is like this. Okay, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So this is going to become 1/8. Okay. A squared to the third is a to the 6th. B squared to the third is b to the 6th. So that's the first part done. Then I have -4 squared. So that's positive 16, b squared, and then that's going to be squared.
Oh, I get it.
Now I need to multiply this squared in. So I'm going to distribute that squared in. So I still have 1/8, a to the 6th, b to the 6th.
That should be a calculus then.
What?
16 squared,
That's ugly.
256.
6 and
Yeah?
6 and 20 and 20.
Rock. Okay. B to the 4. Now, you guys go, oh my God, it's a fraction, yuck. Okay, but it's not so bad. 1/8 is the same thing as saying divide by 8. Anytime you have a numerator of 1 and you multiply a fraction by another number, it's the same thing as dividing by the denominator. So 1/8 times 256 is the same thing as 256 divided by 8.
Yeah.
So I'm going to do that real
Because the
quick.
one would make multiply.
Yeah.
256 with 8 under.
Thank you. So that's going to be 32. A to the 6th times no a's, so I just carry it over. And then b to the 6th times b to the 4th is b to the 10th. So I have 32 a to the 6th, b to the 10th. And that is completely... Okay, so we are going to require a common base, and then we're going to subtract the exponents. And negative exponents are illegal, and we'll talk about that soon.
Dang.
So what we do, g to the 3rd over g. So that's the same thing as g to the 3 minus 1. H to the 5th over h squared. So that's the same thing as h to the 5 minus 2. So this will be g squared h to the 3rd. Now you don't have to write this subtraction step in. I just wanted to show you what we're doing. And all you do is you look at each one, each set of variables individually. So k to the 7th over k to the 5th. So that's 7 minus 5. M to the 10th over m to the 3rd. So that's 10 minus 3. And p over p. So it's 1 minus 1. So that's k squared m to the 7th p to the 0. But p to the 0 means we have no p's. So it's k squared m to the 7th, and the p's have gone away. They canceled each other out. And you don't have to write these two parts in. If you have 1 and 1, they cancel each other out.
Okay.
So you can just get rid of it. Like with raising a power to a power when you had the multiplication,
Got promoted.
we have to distribute that power to every single thing inside the parentheses. When you have a fraction or a division inside, you're going to distribute this 2 to every single part of the fraction. So the 2 will go to the 3, the p to the 3rd, and to the 7th.
Everyone gets power.
Everybody gets the power. So that's going to be 3 squared p to the 6 over 7 squared, or 9p to the 6th over 49. And then we need to make sure that this doesn't reduce before we're finished, which 9 and 49 don't reduce, so we're okay. And it does not matter how many terms are in our fraction. We distribute that power to everything. So there are 6 things that that 4 is being distributed to.
Talk about splitting up something.
So 2 to the 4th. Y squared to the 4th, so y to the 8th. X to the 3rd to the 4th, so x to the 12th. Over 3 to the 4th. Z to the 3rd raised to the 4th, so z to the 12th. And then x to the 5th to the 4th, so x to the 20th. Okay. 2 to the 4th. 2 times 2, 4 times 2, 8 times 2,
12.
16.
Oh, 16. 16.
3 to the 4th. So 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, and now here I have x's on both sides. And this is what I was kind of talking about with, we'll go over this a little bit more with negative exponents. But we need to subtract these. If I do 12 minus 20, I'm going to get negative 8. But I'm not allowed to have negative 8. So what I like to do is I just subtract the exponents, and I pretend it's a tug of war. 20 minus 12 is 8, right? You guys all agree 20 minus 12, 8? 20 was bigger than 12. So 20 wins the tug of war. So I get 16 y to the 8 over 81 z to the 12 x to the 8. So the x stays on whichever side had the higher exponent.
Oh,
Does that make sense?
yeah.
So 20 and 12, right? The 20 would win. If you figure like, if this was a video game, that's your hit points. The guy with 20 hit points will beat out the guy with 12 hit points, right?
No.
Shh, yeah.
No.
Yeah.
There are a number of factors.
Okay,
How
fine.
powerful is the
If
other
it's
guy?
just a matter of you put 2 people next to each other with hit points, and then whoever had the biggest hit points wins, that one would win. Okay, tug of war. Tug of war. This
What's
is
the
a
strength
samurai warrior, and this is me. Who's gonna win?
When and what?
Tug of war. The samurai, right? Like he's gonna be a lot stronger than I am.
Nope.
Yeah.
Nope. Oh, they're trained to be fast, not strong.
Okay, we don't have to get all technical, man.
Anything at all raised to the power of 0 equals 1. So if I say x to the 0, that equals 1. 10 to the 0 equals 1. 1,000,000 to 0 equals 1.
Because normally they wouldn't put up the 0 when they just put up the exponent. There.
So anything to the power of 0 goes. So this whole big long thing right here,
The 1.
I raised it to the power of 0, so it equals 1. This y right here to the power of 0 is a 1, so it goes away. Okay, so this equals 1. Then x to the 5th over x to the 3rd, I'm going to subtract, so that gives me x squared.
How? Why does it equal 1?
Here's why it equals 1. Because remember we did that p over p thing?
Yeah.
And that was p to the 1 minus 1, which gave me p to the 0. But p divided by p,
Because I was using it.
anything divided by itself, right?
Oh, so
P divided by p equals 1.
what's the power of 0 is division? It's divided by itself?
It's divided by itself.
I'm just wondering why the y went away. When it's still part
Because
of
it's a
the
1.
equation.
So if you could put a 1 right there if you want to, But then 1 times x to the 5th is just x to the 5th. So it goes away. 1s, when you're multiplying, 1s go away. Okay. Here's how it works, guys. If you have a number to a negative exponent, any negative exponent, you throw it in the basement. If it's already in the basement and it's negative, you put it up top. Okay, so we don't like negative exponents. So if it's negative and it's a regular expression, you put it in the denominator. If it's a negative in the denominator, you bring it to the top. So here we have n to the negative 5, that's in the numerator, so I'm going to throw it downstairs.
Because hand sanitizer.
That's what I don't understand, if there's no negative exponents, why is there a problem with negative exponents in it?
You can end up with negative exponents, but then you're not really allowed to have them, so you have to move them. It's just like, okay, let me...
All right.
So here I had this negative 5, so I threw it to the bottom and made it positive. Here I have a negative 2, so I throw it to the top and make it positive, and then that p to the 4 was already positive, so it stays where it is. Okay.
You're still talking.
Now, negative 20 is not a negative exponent, so that can stay where it is. Right? I have r to the negative 3 up top, so I have to make it positive down here, and then there was already an r squared, so I'll deal with that in a second. That was positive. T to the 4th is positive. T to the 7th is positive. So it stays. And then u to the negative 5, I'm going to throw it up top. Now this is all kinds of messy and ugly, right? Because I've got r's on both, like r's next to r's, but I was just moving things. That's all I did was move things. So first, let's deal with this 5 and 20. I can reduce that, right?
Right.
Because 5 will go into 20 4 times. Negatives in the denominator are not great, so I usually just bring them out front. This negative 20, I'm just going to bring the negative out front. And then this will reduce and give me a 4 in the denominator. Okay. And if it makes you feel better, you can leave that 1 up top. Okay. R cubed times r squared, I'm going to add those exponents together, and I'm going to get r to the 5th. So I put the r's together. And now I have T4 up top, and I have T7 in the bottom. And I can subtract those exponents, and I get 7 minus 4, right? And 7's bigger. So T to the 3rd will stay in the bottom, because the 7 was in the bottom. Make sense?
Then I guess the u negative 5 would go up.
Yeah, the u negative 5 came up top, so I get u to the 5th up here. And if you want to leave it like this with the 1, you can, but if you don't like 1s,
Can I ask you where the 1 came from?
yes. When I did, basically I took 5/20ths and I reduced it, and it became 1/4. So this is fine. This is good, and this is good. Either of those is acceptable. This over here is not good.
Okay, why was the U5 moved again?
Because it was negative down here,
Okay.
so I had to throw it up top. Because I can't have the negative
Basement,
exponent.
put it in the attic.
You can have a negative exponent in the numerator, basically.
You can't have a negative exponent,
Ever.
not ever.
No side.
You can't have an exponent, negative exponent, except for in scientific notation. That's the only time it's allowed. Guys, I've still got 3 more minutes of your time.
And you recorded that.
That's fine. Okay, let's do this last one, and then we'll be done. 2/10 reduces to 1/5. A to the negative 3 becomes positive 3, right? And I throw it up here. Do you guys want me to combine it in one step or do 2 steps?
One step's
Okay.
fine.
So negative 3 becomes positive 3 and it comes up here with this a squared. So I add it together. B to the negative 3 becomes positive 3. So I add it to this 3 up here. And now look at this. I have negative 5, which is going to go down, and I've got 4, which is going to come up. So this right here becomes c to the 4 over c to the 5. So then that means there's going to be a c on the bottom. Good? Okay.